All right, so here's objective 2 here on inequalities. This one specifically is about being able to write an answer to an inequality in either set builder or interval notation, right? Math has lots and lots of notations. Science has its own notations for stuff. Lots of subjects have its own notation. Even I hear dance has notations for like how you're supposed to write down steps and stuff. Like professional dancers, not like you just go out and do a jig. Anyway, music, of course, has a notation. And I know from watching interviews of, or maybe even reading interviews of bands and stuff, that lots of bands, like musicians, they don't know music notation. They just, pick up the guitar and they start strumming and making music, or drums or drum machines, whatever. They don't know this notation for music. I hope that this wouldn't be a notation they'd know anyway. And I hope also that whenever you look at math notation, this is not what you see. Let's try to clear up the picture just a little bit here. And so, whenever you go to solve a linear inequality, your answer is ordinarily an infinite set of values. Infinite set. We talked about sets in the previous lesson, like real numbers, set of real numbers, set of integers. But like here we're talking about a little bit smaller of a set, but still it's an infinite number of things. Okay, so we want a convenient way to write it. One of those convenient ways is set builder notation. It is a set of things, and I'm going to tell you how to build that set. The first thing you need to know about set builder notation, if you look at the example right down here at the bottom, is that it has curly brackets, or wavy brackets, or fancy brackets, whatever you want to say. One of my students in the past called them J-Lino brackets because, we'll take a look. Whenever I make mine, that one was terrible. My bottoms always end up being bigger than the top, so it looks like a J-Lino chin, if you know who J-Lino is. So this is the way that I always surround my answer in those curly brackets, first of all. Okay, and then I tell what variable it is that I'm talking about. Whenever I solve it, I might have an x in there, I might have a y in it. Okay, so this is the way that I read this statement down at the bottom. The set of all x, the colon, represents such that. The colon that's right there just are the words such that. The set of all x such that x is less than -2. I've just built the set. I've told the condition by which I make the set. X is less than -2. Okay, and there's one little, well, you can change this up just a little bit. See the little colon right there? Some people write the colon, and then some people write this instead. It looks like a vertical line. I tend to think that one might be confused with an L or a 1 or something like that, so I usually write the colon instead. But, whatever, just so that you understand. Set of all x, it's in curly brackets, such that x is less than -2. Okay, so that's what set builder notation looks like. So here is the same equation that we looked at in objective 1. I believe the answer was something like x is greater than or equal to 4. I want to say that was what the answer was. Yeah, okay. And now I'm going to write my answer in set builder notation. So in set builder notation, it's that exact answer, but I'm just going to decorate it a little bit. I'm talking about x, I put a little colon, and then I put my curly brackets around it. Or maybe I take that and I do that such than vertical strip. X is less than or equal to, greater than or equal to 4, another curly bracket. See, it's very simple, very, very simple. But that's not the only notation that we use. There's another one. It's called interval notation. And you got to know both of them. If you're in a pre-AP class, you got to know both of them because they're written, it's interchangeable. Sometimes a question might might ask it in interval, and sometimes it might ask it in set builder. So interval notations have brackets, and like when I say brackets, I mean square brackets or parentheses. It's just another way to write an infinite set of values. Okay. So if your interval notation contains parentheses by a number, the parenthesis indicates that that number is not part of the set. In other words, there's no equal to sign under that number. Like this one. Take, for example, x is less than 2. This is exactly how I'd write that in interval notation. Well, what would be the smallest number in that set? Well, there isn't one because it's everything that's less than negative 2, so I'm going to write down a negative infinity. Notice that right next to negative infinity is a parenthesis because you can never get to negative infinity, right? Infinity itself is not a number, it's just a concept of getting bigger, bigger, bigger without end. Okay. And then a comma, and then I say the bigger number that's in there, the biggest number that's in there, and that's 2. And that 2 gets a parenthesis because there's no equal to sign underneath that less than. Okay? It looks kind of like an ordered pair, right, with the parentheses, but you'd never have infinity in an ordered pair. That'd be silly. Okay, so neither negative infinity or if I have it, positive infinity, neither one of those will ever have that. They'll never have a bracket. They'll always have a parenthesis. Okay, so they're never part of this set. I always get a parenthesis on it. Okay, and always, always remember that the order that you write this stuff in is a small number, comma, big number. So always like that, a small, comma, big. Set builder, small, comma, big. That's weird. Just made that connection. Okay. Now, I could have brackets in it, and I always put the brackets in there if the number is equal to, if like the end point of the interval has an equal to sign underneath it. So take a look at that. X is less than or equal to x. Whoops, whoops, whoops. There we go. I'd write it like this. It would look exactly like the one before, but on that 2, instead of it getting parentheses, it gets a bracket, a square bracket, because it's equal to on that number. Now, I'll just show you something that, like some math teachers, maybe your math teacher last year or 2 years ago or something like that, whenever you're doing inequalities, instead of doing open circles and closed circles, whenever you're going to graph this, so if I put a 0 here and a 2 here, some teachers do this. They go bracket and they color in this way. And for the ones where it wasn't equal, they would put a parenthesis there. So that's where that kind of thing is coming from. Okay, and then the same 2 reminders. So infinity, no matter what kind it is, positive or negative, never get brackets. They always get parentheses, and you always go, again, smaller number, comma, bigger number. Call it, blah, 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 if you could follow that. So let's write that same solution now. Same problem as it was before. This time let's write it in interval notation. It says set builder, and that is a big fat typo, because we already did that, interval notation. All right, so remember it was x is greater than or equal to 4. So when I look at this, I think of a set, a small number and a big number. This is everything that's bigger than 4. So the smallest number in this set is the number 4, all the way up to, and it's getting bigger and bigger and bigger, up to infinity. Okay. Well, I remember infinity always gets parentheses, first of all. And then the 4, since it has an equal sign in it, it's going to get a square bracket. And that's how I would write the same exact interval in interval notation. Now, if you're having trouble with interval notation, I would suggest just looking at the graph for it, because the graph for it makes it very, very simple. So if I put in a 0 and I put in a 4 on there, and I know it's like this, and it colors in that way, I could very easily see what's the smallest thing in that set. Oh, it's the 4, it's colored in, it gets a bracket. Biggest thing, oh, we're talking about positive infinity, and it gets parentheses, always, always, always. Right? Yep, that's right. Okay.